This video is going to go through the test review for Unit 1, Topic 1 and 2, inverse relationships and radical expressions and equations. So our first set of questions, we are being asked to find the inverse of each function and to show some work that can be either a mapping, a bulleted list, etc. So the first thing I'm going to do for every function is I'm going to think about if I were to substitute a number in for x, how would I evaluate the function? So the first thing I would do to that x is I would cube it. After I cube it, I would multiply by 2/3. So cube times 2/3, and then I would subtract 4. So to undo this, I'm going to do the opposite steps backwards. So I'm going to go ahead, and the first thing I'm going to do for my inverse function is I'm going to add 4. And I'm going to kind of work like in the space here, and we'll see how I might need to rewrite it. I'm going to go x plus 4. Okay. Now, the next thing I'm going to do is I'm going to divide by 3/2, but like I don't really, or by 2/3. I don't know why I keep saying 3/2, but maybe because I'm thinking ahead. I don't want to write it this way. It's just big and bulky and ugly. So what I'm going to do is I'm going to write this as x plus 4 times 3/2. Okay. And I can actually distribute the 3/2. Remember, dividing by 2/3 is like multiplying by 3/2. And if I multiply by 3/2, I'll get, 3/2 x. And then 3/2 times 4. Well, 3 times 4 is 12. 2 times 1 is 2. And that gives me 6. Another way to think about it could be like kill the 2's. Make this a 2, and then 3 times 2 is 6. So I'm going to grab my eraser again, and now I'm at 3/2x plus 6. Okay. Now to undo my last step, I'm going to cube. So cubing, the opposite of cubing is to take the cube root, and here is my inverse function. Again, PEMDAS told me first I apply the exponent, then I multiply, then I subtract. So number 2, this square root acts like the P in PEMDAS, like parentheses. So I'm going to work everything under the root first. And the root itself acts like the exponent. So for parentheses, and I'm going to stop writing them underneath only because it gets squishy. The first thing I would do if I put a number in for x is I would multiply by 5. So I would have 5x, and then I would subtract the 1. Okay, so now I've got 5x minus 1. Now I'll take the square root. And then the last thing I will do is add the 6. Right, so actually I'm going to write these times 5 minus 1 root plus 6. So now we are going to undo this. So we're going to say x plus 6, and then we're going to square it. And then we're going to add 1. And then we are going to divide the entire expression by 5. You also could multiply the entire expression by 1/5. Oh, that came out kind of ugly. So we're going to label it with its name. Its name is G inverse because the original function was G. All right. Number 3, when I map out H, in the parentheses happens first. So it's going to be x plus 1, and then square it, and then multiply by -8. And then subtract the 6. This is very long. All right, so let's undo it. So the last thing I did was subtract 6. So I'm going to start by doing the opposite step backwards. I'm going to add the 6. This is why I kind of like writing the arrows, because then I know like what I need to undo. Like here, over here to here, this was times 8. 6 plus 1, this was square. All right, so now times -8. I'm going to divide by -8. I could multiply by -1/8. Now, here's the thing. I'm still going to get fractions. I'm going to get -6/8, which becomes -3/4. It's not really any beautiful, so I'll leave it like that. The opposite of square is to square root. Subtract the 1. I did the square. I subtracted 1. And its name is h, so it's going to be h inverse. All right, and our last one is a little particular. Notice k of x has this negative sign. I'm not like negating, I'm really multiplying the whole thing by -1. It's a little squishy, but here we go. I'll put a little barrier. All right, so we take the x, and obviously the first thing we're going to do is we are going to subtract 4. And then the next thing we are going to do is cube root. And then the next thing we are going to do is multiply by -1. And that will make it -3rd of x minus 4. And the last thing we would do is subtract 2. And I don't have enough room to write the whole thing, so we'll just know that this would be here. Now let's undo it. So the first thing is to add the 2. And now the next thing to do is divide by -1. Now, I could write it like this, but this is really not acceptable because we can very, very easily divide x plus 2 by -1. And we get -x minus 2. Divide the x, divide the plus 2. Again, so like we had x plus 2, divide them both by -1, and there we go. Okay, now we are going to cube this expression and divide it by, oh, not divide it, that's a lie, add 4. And we get k inverse. All right, for the following functions, graph the original function and its inverse function and find the properties of both the original and the inverse. So I'm going to start with the original function, and I notice that it has a vertex of -3, +2, because it goes left 3 and up 2. So left 3 and up 2, and I'm going to just put that point down. Now I'm going to go -4, -5, -2, -1, and I'm going to do some evaluating. So first I'm going to put -5 in. -5 plus 3 is -2. Squared is 4. 4 plus 2 is 6. And because this is symmetrical, I know this is also going to be a 6. Now let's put -4 in. -4 plus 3 is -1. Squared is +1. Plus 2 is 3. So let's see, I got negative. Oh, whoops, I put that one in the wrong spot. Oopsie doopsie. No, I didn't. That's a lie. -4, 3. -5, 3, 6. -2, 3. And -1, 6. Here's my function. It is a beautiful quadratic. All quadratics have a domain of all real numbers, and this particular quadratic has a range of y is greater than or equal to 2. Now, when I go to graph this inverse function, I'm not going to graph all 5 points because if I do, it's going to look like this and it won't be a function. So I'm going to cut off the bottom. And so in order to do that, when I take this and flip it, you'll see if I take the vertex, it's going to become 2, -3. And then if I take, let me switch colors. If I take this point, -2, 3, 3, -2. And now I will take, actually leave it in red. We'll take negative 1, 6 becomes 6, negative 1. We get that nice top piece. I'm going to do this in yellow and then I'm going to undo it. If I took this point here, negative 4, 3, and graphed it, I would be here. And if I took this point and graphed it, I would be here. And now you can see my graph, the red and the blue together, does not pass the vertical line test. It is not a function. So I'm going to cut off the bottom because when we take square roots, we use the positive value. The square root of 4 is 2, just 2. So here is our inverse function. It has a domain of x is greater than or equal to 2 and a range of y is greater than or equal to negative 3. Okay, so now I'm going to go to number 6. And I see number 6 also goes left, but it goes left and down. So let's make a table. Negative 1. Negative 4, I'm going to use 0, 1, negative 2, and negative 3. And guys, I'm actually going to sub in the 0 and the 1 because it just seems happier. Like I'd rather put the 0 and the 1 in. So I've got negative 0 plus 1 cubed. Oh no, this is cubic. I got to do all of them. Poops. Okay, I'm not writing all. I'll write out the first one, but I'm not writing out all of them. That's a lot of writing. I don't have enough room. Okay, so here we've got negative 2. Cubed would be negative 8. Now this negative outside is like a negative 1 times. Negative 1 times negative 8 becomes 8. 8 minus 4 is 4. Now if I put a negative 2 in here, negative 2 plus 1 becomes negative 1. Cubed is negative 1. Times negative 1 is positive 1. Minus 4 is negative 3. Do it again here. And then we can go negative 1 times 0 plus 1 cubed minus 4. That's just a 1. 1 cubed is 1. Negative 1 times 1 minus 4 is going to be negative 5. And then if I make this 0 into a 1, 1 plus 1 is 2. 2 cubed is 8. Negative 1 times 8 is negative. It's going to be negative 2. I don't think this is going to fit. That's okay. All right. Go back to blue. And we've got negative 3, 4. We've got negative 2, negative 3, negative 1, negative 4, 0, 5, and that other one's not going to fit. We're not going to die. It'll be okay, although I did miss that point. Let's try again. It's okay if not every point fits. It's not the end of the world. Just bring it down like that, but hopefully it's nicer than mine. Okay, the domain is all real numbers. The range is all real numbers. This graph stretches from left to right and bottom to top. Now, this graph, let's do the inverse points one by one. First, we've got 4, negative 3. Then we've got negative 3, negative 2. Then we've got negative 4, negative 1, negative 5, 0, and the other one would be like negative 12, 1 would be like somewhere over here. So this graph is going to look, and I don't need to restrict its domain because the inverse is a function without any restriction. Remember, a parabola, when I flip a parabola over the line y equals x, kind of becomes like a C, and that's not a function. Okay, moving on. All right, graph the following function and identify the properties. We've got some nice square root functions here. So the first thing I notice is this is a square root function. So the only numbers I want to put in my x column are numbers that are going to make the square root equal to 0, negative 1, 4, and 9. So I'm going to have a little thinking to myself here. I'm going to think to myself, negative x plus 3 equals 0. And I'm going to solve that in my head. Subtract 3, divide by -1, I get 3. So the first x value I'm going to substitute in is 3. Then I'm going to think negative x plus 3 equals 1. Subtract the 3, divide by -1. Subtract the 3, divide by -1. Subtract the 3, I would get 6, divide by -1. Okay, these numbers now, when I substitute them in, are going to be beautiful and perfect. So I'm going to erase this scratch work so I can use this for some other arithmetic. And I'm going to say 2 times the square root. Now, the negative is part of the formula, so negative, and then the 3 plus 4. Well, this is just 0. 2 times 0 is 0, plus 4 is 4. Beautiful. Now we're going to go 2 square root. Negative is part of the formula. 2 is my x value, plus 3. Negative 2 plus 3 is 1. The square root of 1 is 1. 2 times 1 is 2. Plus 4 gives me 6. Now I got 2 root negative x, and the x is a -1 here, plus 3 plus 4. Negative 1 is 1, plus this is a 4. Square root of 4 is 2. 2 times 2 is 4, plus 4 is 8. Now we got the last guy, 2 square root -6 plus 3 plus 4. This is going to be a 9, and the square root of 9 is 3. That's going to be 6. This is going to be a 10, which I don't think that's going to fit, but that's okay. We've got 3, 4. Ooh, this one go flippy flippy. We got 2, 6. Then we got -1. I did not pick a big enough grid. We can go to 8. That's okay. And then I'm just going to kind of know, just so I kind of know where I'm going with my graph. This is 4. Here's -6. Here is 7, 8, 9, 10. Look at that. We're going to live. And our graph looks hopefully smoother than mine, like that. It has an endpoint of 3, 4. It has a domain of x is less than or equal to, because it goes to the left, 3. A range of y is greater than or equal to 4. This graph actually does not increase. I know the arrow points up, but as I travel on the graph from left to right, it actually goes down. So we're going to say none, and whenever x is less than 3, this graph is decreasing. Okay, we've got another square root function, and this one's kind of easier. I might just do these in my head because like x minus 3 equals 0. I know my first x value is going to be 3. And then if there's a 1 here, that's going to be 4. And then if I make this equal to 4, that's going to be 7. If I make this a 9, because I love my perfect square numbers, it's going to be a 12. Okay, so I'm going to substitute these in. The -1/2 is a little tricky, but, you know, again, we're not going to die. 3 minus 3 is 0. Well, that's nice, because then this whole thing is just a big fat 0. Minus 2 is -2, and that's our endpoint. Okay, now let's sub in 4. -1/2 square root of 4 minus 3, which is a 1. Square root of 1 is 1. So -1/2 times 1 is just -1/2. Minus 2 is going to be -2.5 or -2.5. It's easier for me to write that. So now we'll go 7. -1/2 square root 7 minus 4 minus 2. Well, oh, so that's a 3. 7 minus 3 is 4. So we have -1/2 times 4, which is -2. It's like 4 over 2. minus 2 is negative 4. And now we'll do the 12, negative 1/2. 12 minus 3, and then the minus, this is 9. This one's a pain in the butt because I have the square root of 9 is 3. I have negative 1/2 times 3 minus 2. So I have to know the negative, I mean, numbers are flexible. I can think about these numbers as decimals or fractions. I personally think it's easier to graph with a decimal. So I'm going to think about negative 3 over 2 as negative 1.5 minus 2 is going to be negative 3.5. All right, so here we go. 3, negative 2. One mark. 3, negative 2. 4, negative 2.5. 7, negative 4. And the other one's going to come out over here, although it's not going to fit so good. Okay, so here we have a domain of x is greater than or equal to 3. A range of y is less than or equal to negative 2. We have another graph that never increases, only decreases. Another graph, but this one I notice is a cube root. So when I see a cube root, I'm not thinking about 0, 1, 4, 9. I'm thinking about negative 8, negative 1, 0, 1, and 8. And I'm going to let x minus 4, I'm going to let x minus 4 equal these numbers. So if I add 4 to both sides, x minus 4 equals negative 8. This is going to be negative 4. This is going to be 3, 4, 5, and 12, which obviously is not going to fit on my graph. So now I'm going to sub these in. I'm going to work the first 2, and then after that, I'm going to do them in my head. So we have negative 4 minus 4. Okay, the cube root of negative 8 is negative 2. Now we have a negative out front. So now we really have 2 minus 2, so this is going to be a 0. Then we have negative cube root 3 minus 4 minus 2. Well, this is negative cube root of negative 1. Well, the cube root of negative 1 is just negative 1. So that's going to be 1. 1 minus 2 is negative 1. When I put the 4 in, I get 0. So this whole beginning part is just 0 minus 2 is 2. Put the 5 in, I'm going to get 1 under the root. The cube root of 1 is 1. Negate it, negative 1. This is negative 3. This is probably about negative 4. Yep, 12 minus 4 is 8. Cube root of 8 is 2. Negate it, you get negative 2. This is negative 4. So our graph is going to look like negative 4 is 0. 3, negative 1. Oh, whoops, I missed. 3, negative 1. 4, negative 2. 5. There it is. Negative 3. And then the next one's going to be like way over here somewhere. I'm just going to aim for it. I'm hard on the tablet. Ooh, I almost missed. Oh, this is ugly. This is so ugly. There it goes. Okay. But the properties are nice. Cube root functions always have a domain and range of all real numbers. My point of symmetry is 4, negative 2. Man, all these are decreasing. So weird. Nothing's increasing. The whole thing is decreasing. It's always going down from left to right as I trace it. Down, 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 down. All right. Moving right along with number 10. Okay, number 10, what restrictions need to be placed on the following functions to ensure their inverses are also functions? So what I want to think about on these are all parabolas. I see square, 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 and I also notice they all open up because there's no negative. So they're all looking like this. So my goal is to figure out what is this vertex, and I want to keep the right side. So here in the parentheses, I see I have a vertex of negative 1, 4. So that x value is negative 1. I want x is greater than or equal to negative 1. Over on letter B, I have a vertex that a 9? I wrote on top of it, I can't see. Yes, it's a 9. Is 9, 5, so x is greater than or equal to 9. Letter C, 7, 14, x is greater than or equal to 7. Letter D, vertex is at negative 8, 11, so we're going to use x is greater than or equal to negative 8. Number 11, simplify each expression. Express your answer in rational form. I'm actually going to start by putting everything in rational form. I noticed number 11 has 2 roots. The closest root to the x is a square root. And then I also have this 5th root. So I'm going to take x to the 1/2 and raise it to the 1/5. Power to a power, we multiply the powers. 1/2 times 1/5. Oop, I just wrote the answer. 1/2 times 1/5 is going to be x to the 1/10. Number 12, the denominator, the cube root, I'm going to make that a 1/3 power. Now, the numerator has a power of 1, and I know when I divide, I subtract the powers. So I don't want to put a 1 here because 1 minus 1/3 could be painful. So instead, I'm going to cut my 1 up into thirds. And now I have 3/3. So 3/3 minus 1/3 is just 2/3. I can't forget about my coefficients. Now, coefficients, we are just going to divide normally. I have a 2 in the numerator and a 1 in the denominator. And when I divide those, I just get 2. All right. Number 13, I have a 5th root. And I have a 3rd root. When I multiply, I need to add the powers. 1/5 plus 1/3. I'm going to create common denominators. So now I have 3/15 plus 5/15. I did not write that in the right spot. That's okay. And when I add that together, I'm going to get 8/15. So I have x to the power of 8/15. Now, the next set of directions is a little different. It says simplify each expression and write your answer in radical form. So I noticed that I already am in rational form, and I have a power to a power situation. I'm going to multiply 2/3 times 1/2. When I multiply across, I get 2/6, which is 1/3. And x to the 1/3 in radical form is going to be the 3rd root of x. Here I need to subtract the powers. I have 3/4 minus 2/3. I need common denominators. The common denominator between 4 and 3 is 12 because that's its least common multiple. So this is 9/12 minus 8/12 is 1/12. And x to the 1/12 is like the 12th root of x. Okay, now number 16, I got a lot going on here. I'm going to take care of what's in the numerator first. I'm just going to deal with this. So here I add the powers, and I just get x to the 1st over x to the 5th. When I subtract those powers, I get x to the negative 4th. Now I'm going to worry about what's outside. Now I'm going to worry about the 1/2. Power to a power, we multiply the powers. Negative 4 times 1/2 is going to be negative 4/2, or negative 2. Now, it says in radical form, but this is a whole number, so we're obviously not going to make it a root. We are, however, going to write it as 1 over x squared. Now we have some solving equations. I am going to do PEMDAS backwards. Anything I need to do backwards to get the x by itself. So the first thing we're going to do is add or subtract away. And this gives me the square root of x plus 3 equals negative 1. Then there's really no multiplying or dividing here, but this acts like an exponent, so I'm going to square both sides. X plus 3 equals 1. Take care of what was in parentheses. what was under the radical acts like parentheses. I get x equals -2. Now, because this is a radical equation, I need to check my answer. So I'm going to go 2 plus the square root of -2 plus 3. -2 plus 3 is 1. 2 plus the square root of 1. That's just 2 plus 1, which is 3. And that is not going to work out because it's supposed to be a 1. So we say here we have no solution. Now, you could have stopped at the blue. You do not need the red. You can realize that the square root of x plus 3 can never yield us -1 and immediately go to no solution, and that is perfectly acceptable. Number 18, again, I'm going to subtract first, and I have the cube root of x equals -2. Now, it is perfectly acceptable to have a cube root that results in a negative number. If I cube both sides, I get x equals -8. Now, just for funsies, if I check this, cube root of -8 is -2. -2 plus 4 is 2, which is what it's supposed to be, so we are happy. I only need to check square roots. Now, 19 and 20 are written with rational exponents, but here, this is just like a square root, and this is just like a cube root. I'm going to start number 19 by subtracting 8 from both sides. That gives me 9 equals, I'm actually going to write this as the square root of x minus 5. I'm going to square to get rid of the square root. I'm going to add the 5. I'm going to check 8 plus 86 minus 5 with a 1/2 power rule. This is 81, and that's like a square root. Square root of 81 is 9. 8 plus 9 is 17. Happiness abounds. You work. Box of joy. Now, here, there's nothing to do but cube. So I'm just going to cube both sides because there's nothing else going. Like, that's just like 3 equals the cube root of x. So we're just going to cube. And 3 times 3 times 3 is 27. So for those of you who are having a moment, oh my God, 4 times 27. Well, I know that 4 times 20 is 80. And I know that 4 times 7 is 28. So this is going to be 108. Alrighty, last page. Last page? Is it the last? Yes, it's last page. All right, last page. We've got another solving. Oh, this one's a little trickier. So this is really a good PEMDAS example. So remember, last at PEMDAS is add or subtract. So I'm going to add the 2. That's going to give me 3 root x plus 7 equals 27. Then multiply or divide away. So like literally peeps. MDAS. We did this. Check. Now we're going to do this by dividing by 3. And we've got root x plus 7 equals 9. Now, the exponent is like the root because we're going to square both sides. We've got x plus 7 equals 81. And last, the parentheses is what's under the root. So I'm going to subtract 7 from both sides, and I get x equals 74. That's right. Okay, so real quick check, because it is a square root function. 3 root 74 plus 7 minus 2. 74 plus 7 is 81. That's beautiful because the square root of 81 is 9. And 3 times 9 is 27. And 27 minus 2 is 25. And that is happy. And you, my friend, get the box of joy. You are a solution. All right. I got graph the function. Ooh, what was that all about? Graph the function and its inverse function and find the properties of both. So right here, I see I've got 1, 5. Is my vertex. and I see that it opens up because it's not negative in the front, so it's going to be x is greater than or equal to 1. Because the vertex is 1, 5. Oops, I said 1, I meant 5. Because the vertex is 1, 5, I know that the restriction needs to be x is greater than or equal to 1. 2, 3, 0, negative 1. I'm just going to real quick sub in 2 and 3. And then because it's a parabola, I know it's symmetrical. 2 minus 1 squared, that's a 1. 1 squared is 1. 1 plus 5 is 6. 0 minus 1 is negative 1. Square it is 1. Wait a minute, what the heck? Just, oh, because I put this one in. I'm stupid. Wait. I went too fast. Sorry, my brain was going fast. My hand was going faster than my brain. Say 1 plus 5 is 6. And that goes here. And that goes here. I'm like, wait, these are the same. Right now, I'm going to do 3. 3 minus 1 is 2. Squared is 4. Plus 5 is 9. This is so not going to fit. I'm just going to put these two down. Call it a day. Now, when I go to do the inverse, I'm only doing greater than, so I'm just going to use these points. I've got 1, I've got 5, 1, I've got 6, 2, and the other one's going to be over here. So the domain is going to be x is greater than or equal to 5, and the range y is greater than or equal to 1. They're inverse functions, these switch. Not surprised. And then the last question. Now this one, there's something about this that messes people's heads up. Guys, the vertex here is just 0, negative 3. Joy of joys. It opens up also. So I'll go 0, negative 3. And I'm just going to use the pattern here because I know that pattern for a regular parabola that doesn't have any kind of dilation or any kind of stretch or shrink. There's not a number here other than 1. So I'm just going to use that pattern where I'm like boom, 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 boom. You can make a table if you want. You get the same values. Arrows or to the end of the graph, please. And the inverse, I'm going to take the point 0, negative 3. I've got negative, this one will be ugly, it's going to like overlap. I hate that. So I did this guy. Now 1, negative 2 becomes negative 2. Oh, yuck. 1. And then 2, 1 becomes 1, 2. And we've got x is greater than or equal to negative 3 and y is greater than or equal to 0. If you use this video to do the entire review sheet, you need to go onto Google Drive, print out another copy, and try it by yourself. You must be able to do the problems confidently alone in order to be fully prepared.